All right then, so this is going to be the second actual PLC code, and we're going to pick up from the point we left off. Now, I did notice a couple mistakes. Number one, we have this, I just did copy and paste, and a lot of times when you copy and paste, you just forget to change the addresses. So I really need this to be my close limit switch goes to close limit, and we run that through edge triggers. So this guy down here, the C7, is really C10. And be careful when you're copying and pasting, because I do it all the time. And if you think it's right, you go through the program and it'll look wrong. Now, the other thing I wanted to say is, you know, we're running these the switches through the same type of circuit as we do for the inputs. And, you know, we say, well, why are we doing that when they're internal bits and they're not actual inputs to the PLC? But remember, these switches would normally be external to the PLC, so those are just being connected kind of in the same fashion as the actual input bits would be connected. So down here, what we're going to do is we're going to have this counting at 10 times a second, and this is going to count up to 10 seconds. And when we get 10 seconds, we're going to say our door is either open or it's closed. And so how are we going to count? So we're going to count is, well, we're going to be in the start process. So our start process, let's go in here, and that'll be our C1 bit. And then we want to also have the motor up. So when the motor is up, that'll be Y004. And then we're going to, when we're not in this time, well, this timer reset, or the timer is going to reset itself. So it'll be normally closed, it'll be T1. And then we're going to do the same thing for when we're doing it for the down count. So we can just say, well, we can actually put a branch right below the just the motor up, so we can add a row beneath it, and then we'll say we're also going to do that if we're counting, or if the motor is up. So it'll be Y005. And then we'll just line it up and connect it up. So we still need the start process, and we still need this minus T1. So let's go into our line function, line mode, and we'll connect it up here and connect it up here. Yep. Try to connect it up there. Okay, and we're good there. So that's when we're counting. And let's give these guys a name. So this T1, what it really is, and its function is going to be, and we need to get to T1. So T1, this is going to be my door, and it'll be a simulation timer, because we need to simulate it somehow. And then this thing down here, we'll call it a door, or this CT1, we'll call it a door simulation counter. And that'll be counting pretty much seconds. And we can give those guys names, and that'll help us. So now, what are we going to do for, when are we counting? So we're counting first. This counter needs to be an up-down counter. We have it up and down. So we count up when we're going up. So that's going to be a normally open contact, and that'll be Y004. And so that moved this, well, I did not put that where I wanted to, so I'm going to delete that. And again, you have to make sure that these are where you want. So I'm going to put normally open here, Y004. And it's also going to count when we get the output for this counts out. So it's going to be normally open T1. And then it's going to be, we're going to, I guess, not count up when Well, we can say oh, so we want to say that we stop this timer from counting for sure. I was just looking at this. So we want this to be actually a normally closed. What we have to do is we have to inhibit this guy from counting when this other one times up. So we're going to stop that from counting. And so down here, so when this finishes counting to 120, it stops. Now, actually, what we're depending on it stopping counting is when we see the actual limit pulse. But we're going to put that in as a safety barrier, I guess. Now, to count down, it's just going to be our normally open contact, and that'll be Y005, and also T1. Okay, and then we'll line that up. We'll go in there. Now, for our reset, we're going to just use our usual normally, and again, I put it in the wrong spot. I want to be over here. So this is going to be normally open, and this will be X003, which is our normal reset. And I'm also going to put, as we've had shown in the previous videos, the normally closed contact, and this will be C1. So when I'm not in my start process, I'll also reset. So I'm going to line these up, connect that up, and then over, and that'll be good. Now, I also have another timer that I want to time, and this is going to be to simulate a fault. And how are we going to do that? So what we have is when we count up or we count down, we're counting for 12 seconds basically. So if I count beyond 12 seconds, something's wrong. So I'm going to go over here. I'm going to put another T on timer, and I'm going to make this T2, and I'm going to set this for 15 seconds. So we should normally just stop counting at 12 seconds. If we get up to 15 seconds, something's wrong, and we're going to say that's a fault. So how are we actually going to say? So what's going to happen is if I'm counting up, or if I'm moving up, my door is moving up, so Y004, if I do not see my open limit switch, and my open limit switch is going to be close limit switch. So C6 and then C9 are open and closed. So if I do not see this, which means it's normally open contact, and this will be C6, then I'm going to say that's a fault. Now, I guess I need to, and I'm also going to do that again for if I'm going down, so 005, and we said the other one was normally closed contact, so that was C9. So we have to see that switch take effect. So when the switch goes high, this will go low, and this will, again, the counter will be disabled, so it will never see the terminal count. And what we can do is we can line those up together. And so I'm going to line them up, put them in the line mode. Now we also probably need to make sure we're in the start process. So anytime we have a counter, we don't want it free running, so we want that to be in there. Now the other thing I'm going to need, I was just thinking back in my mind while I'm talking, is we're going to need something for a fault reset. So we're going to have a fault circuit. So let's see what number I'm at. So for C's, I am right at, so I'll make it C13. I'm going to call this fault reset. And I better call that before I forget what E is. So C13 will be my fault reset. And that'll be a circuit that we'll put in later. But now let's put in the actual fault signal. So what happens is if this ever gets to a timeout, so if this ever goes high, so this will be T2. If that ever goes high, we're just going to declare that a fault. And so we'll just go to the output, and so we had C13, this will be C14. And I'm going to call this a system fault. and I might as well call that, give it a name right now. C14 will be my, well, not system, well, I don't know, why not? System fault. And basically means the door's stuck or something. It's not working. So that'll be my system fault. Now I'm going to seal that in. So I'm going to insert a row. And again, normally we seal in the output contact. And now the only thing that we're going to unseal it with is the fault reset. So if the fault reset will be the thing that unseals this, and it re-enables this timer. So this will be a normally closed contact, and this will be my C13, and I'll line that up. So when this counts up to 15, it's going to latch this circuit. The only thing that unlatches this circuit is the fault reset. So then the system fault goes away, and the when we hit the fault reset, we enable the timer again. So this fault goes away. If we still have a fault, it'll count out for another 15 seconds, and then the fault reappears. And that's the way we are going to do it. So now, I guess I had forgot, what we want down here is, I want to put a compare. And so I am going to take my CTD1, which is the 12-second counter. Yep. CTD1. Oh, so I need to, well, what's wrong with that? CTD1. Oh, I need a value over here. So when that equals 120, so when we're counting up and it equals 120, that's when I want to say my open limit switch is, enabled. And I think we said that was C6. So that's our open limit switch. And then when we're counting down, so I'll put another compare in here. It'll be the same CTD1. And when it equals 0, that's going to be my close switch. And I think we decided that that was C9. So we'll put in C9. So now I have generated, I'm simulating those contact closures. And now, so now, one last thing that I want to do, and probably, well, I'll just put it in here. I want to somehow make it fault. I want to create a fault. I want to create a situation where I have a fault. And we said that, what we have is we have this switch over here, and we have switches to simulate. I'm pressing the open garage door, so I want it open, I want it closed. The last one we said was going to be to inject a fault. So we're going to make that an only open contact, and we said that that was X007, and that is fault inject. So when we do that, and now I'm only going to do it for the down motor, because that's, if you can, well, I suppose, well, we're going to do it when we're closing the door. There's really no obstruction when we're going up, so we'll say that we have to be going down. So that'll be Y005. So we're going to inject a fault, and we're going to put it in there. And what we're going to do is we're going to stop our timer from timing. So we're going to use another compare. So we got another compare, and again it'll be CTD1. Okay, CTD1. And it's going to be when that equals 50. So when we're counting down from 120 to 50 is when I'm going to stop it. So I'm going to go out here. I gotta move it up so we can see. I'm going to put this output. And now, let's see, I think we're up to 13 or 14. Anyway, okay, 50. And what this will be is this will be a fault injection signal. So let me give it a name. Okay, fault inject. And so how am I going to use that signal? actually, what I'm going to do is I'm going to go back up to my counter and where we had it. And so I've got to change this. So when we were counting down, if I have this signal, and first let me give it a name. So C15, it's fault inject. Okay, so this signal will go high. So I was trying to give it the same name as that name. So instead, I'll call it fault inject bit. Okay, so this is the bit that I'm going to use to put a fault in. And so how am I going to do that? So when we're counting up and we're counting down, we're just depending on these things to count up and down. So when that goes high, I want to stop it from counting. So I'm going to put a normally closed contact, and I'm going to make it my fault inject bit. So that is going to prevent it from counting. So it's never going to count down to 0. It will count from 120 down to 50, and then it will stop. And when it stops counting, since it'll never get to, the motor will look like it's down, 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 this will actually hit 15 seconds. So that's fault inject will stop it from counting. This will time out, and then we've got our fault. And I think that'll be okay. So what else do we need in here? I guess the last thing we have is the door cycle thing that we said we were going to. I don't know why we put it in there, but I said we were going to. So it's Y004. When we go up, okay, and then we hit the open limit switch, and that's C6 we said. So what I'm going to do here is I'm going to say that'll be in output. I think we're at C16. Okay, and I'll give that a name, and I'll call that door cycle. Okay, and that'll be good. And also, so I'm going to latch that in. So I'm going to add a row after it, and I'm going to again do our usual latch in with C16. And so what is going to happen is when it goes up and it hits that limit, it's going to be high. Okay, and then when it comes all the way back down, we're at the closed limit switch. And so when that goes high, I want it to interrupt the signal. So again, that's going to be regular, normally closed contact. And so when it hits the, when it goes all the way up, this will go high. When it goes all the way down, it'll go back down low. So I'm going to line this up. And so what am I going to do with that? So I am going to take this, and I'm going to, that mode, I'm going to go into a counter. So I'm going to make this my CTD2. And now actually my set point, I don't care what it is, so I'm going to make it 9999. A really big number. Let's see. Counter number. Oh, so it's not CTD, it's CT2. Remember, the counters are CTs, the value that we're counting to is CTD. So, let's see. I'm going to put my reset in for it. So this will be a normal reset. So I'm just going to put my normally open contact down, make this X003. But let's think about it. Now, how are we going to count this? So our signal for the door cycle, it goes to a high level, and then when it comes all the way down, it goes low. So what we need here is we need an edge contact, but this one is going to be a falling edge. So when we see the falling edge of this door cycle signal, which is C16, then that's when we count. So again, we normally use these signals on the rising edge, but this will be a falling edge. Now I'm going to line this up and see that we're kind of getting at our 20-minute endpoint. So I think I've got everything that we said we were going to put in there. Now, what I'm going to do is, the only thing left is I want to put in my lights. And I've got my stack light to help us out. And we're going to have to put in some lights that'll do some different things. And I think when we see a fault, as usual, we're going to do our red blinky light. And we'll try to put in some other lamps. And we'll get to that next time. So I guess this PLC program is going to be 3 programs long, which probably means the HMI will probably be about 4 or 5. So anyway, we'll just see it next time, and we will finalize it next time for the PLC, and we'll kind of load it in and give it a whirl and see what it looks like. Okay, we'll see you then.